Refraction. We have all seen rainbows, those beautiful ephemeral displays of light that are produced during rains. We have also seen the same thing happen on a much smaller scale with prisms and gemstones. These effects are all demonstrations of refraction, light reacting to a change in its medium of transit by bending at the boundary between two media. A demonstration of the effect can be arranged using a slab of any transparent material. Light is incident across two parallel planes or faces and seen to be displaced to the side. This effect is also called lateral displacement. Light undergoes this effect whenever its speed changes. The greater the mismatch in speed between two media, the greater the lateral displacement. Let's understand what is going on with an activity. Let us say that we have a transparent glass slab with two parallel faces. We fire a beam of light at an angle to the topmost face. As the light is approaching the interface or the boundary between air and glass at an angle, it is bent at this interface or this boundary. The light is entering at an angle I with the normal. The normal is perpendicular to the boundary between air and glass. As light is entering from a medium where its speed is high to a medium where the speed is low, the light will bend towards the normal. This bent beam of light will then travel unaltered through the glass. On the other side, as this light now emerges again into the air, it is moving from a medium of low speed into a medium with high speed. Here, the same light which is now emerging from the boundary will bend away from the normal. The bending of angle in both these cases is equal and opposite. As a result, the paths of the light entering the slab and leaving the slab are parallel to each other but displaced to the side. The displacement will be proportional to the mismatch in speeds. The greater the difference in speed between air and this medium, the larger the displacement will be. So, based on these observations, let's pin down the laws of refraction of light. The laws of refraction. The incident ray, refracted ray, and normal all lie on the same plane. And the other is the ratio of the sign of the incident ray to the normal and the sign of the refracted ray to the normal will always remain constant. This second law is also called Snell's law in honor of Willebrord Snell. The refractive index. We just discussed that refraction is caused due to a mismatch in the speeds of light between two media. But how do we show this quantitatively? How can I express this in terms of numbers? We can represent this ratio with the following formulae. The refractive index of medium 1 with relation to medium 2 is equal to the ratio of the speed of light in medium 2 to the speed of light in medium 1. Conversely, refractive index of medium 2 with relation to medium 1 is equal to the ratio of the speed of light in medium 1 to the speed of light in medium 2. The refractive index of any medium with respect to vacuum is called the absolute refractive index. Please note, all media apart from vacuum have a lower speed of light. The refractive index in absolute terms can never be less than 1.